afternoon. Let me thank you all for coming here today. First of all, let me introduce myself. My name is Yarina Pizniuk. I am on my third year of bachelor's in KPI named after Igor Sikorsky. The subject of my presentation is, of course, my future specialty. I've divided my presentation into sections based on the questions, and the first of them is: what motivated you to choose your specialty? Material science is a discipline on edges of chemistry, physics, and engineering, which makes it quite fascinating. It's a diverse area of study and it provides a lot of career opportunities. I was interested in material science because it provides opportunity for innovation. And the next section is how important your specialty is in developing the Ukrainian market. Well, promising materials are important for economic safety and human well-being, as well as for use in industries aimed at solving problems related to clean energy or national security. However, it can take 20 years or more to transfer a material from initial discovery to the market. Therefore, accelerating the pace of discovery and deployment of advanced material systems will be crucial to achieving global competitiveness in the 21st century. There is no doubt that to transform Ukraine into a high-tech competitive state, the material science priority should be at the center of its attention. Among the more specific super-priorities, there is a need to intensify in-depth research and development of functional materials, including those for biomedical use and developments no longer only at the atomic dislocation level, but also pico level, such as controlled displacements of atoms and distortions in the crystal lattice to heal the weaknesses within the separation. These super-priorities bring us to the next point, which is: what are the recent trends in the field your specialty related to? As you can see from this table, the recent trends in material science are sustainability, nanotechnology, lightweighting, material informatics, smart materials, additive manufacturing, advanced composites, graphene and 2D materials, surface engineering, and materials management 4.0. What special subjects are required to study to become an expert? As I mentioned earlier, material science is relevant to different fields. It is deeply rooted in science and mathematics, thus requiring individuals willing to pursue this career to undertake studies in chemistry, physics, and advanced maths. Specialized subjects we study are metal science, structural analysis of materials, crystallography and crystallochemistry, 3D modeling, theoretical and applied mechanics, and others. So that poses questions: what do we study all this for? What do we have to know to become an expert? Or to put it differently, what the expert has to know? And the answer is: how the conditions of obtaining and various factors, temperature, pressure, irradiation, environment, conditions of use, influence the structure of materials, their physical, chemical, technological, and operational properties, and methods of controlling the properties of materials. Another question is what the expert has to be able to do. And it's a lot of things, really. The expert in this field has to be able to develop new energy storage sources and devices, create new construction materials and electronic equipment materials, create powder and composite materials, create materials for thermoelectric and electrochemical energy sources, create massive magnetic and nanomagnetic materials, develop new nanomaterials, nanofilm, and single crystal materials, identify and pose problems in the field of material science, make effective decisions to solve them, critically analyze and predict the characteristics of new and existing materials, reasonably select technologies for the manufacture, processing, testing of materials and products for specific operating conditions, organize and carry out comprehensive testing of materials and products, develop research, methodological, scientific and technical programs, apply specialized advanced methods of analysis and forecasting of the materials market, strategic planning of industry development. It's a lot of knowledge and work. It all seems tedious, but I like it because material scientists and engineers help to make advanced materials that benefit the human condition, such as conducting polymers, superconductors, materials for solar cells or thermoelectrics, copolymers, and such others. It's a very innovative field, and of course there are some other benefits. As a material engineer, I will have the skills to enter a wide range of careers. For instance, I will be able to work with innovation, product development, quality and environmental management, research, development of new materials and purchasing new materials. And the most important of this for me is innovation, because it allows me some freedom and I can create new materials and some new techniques of work with these materials. And that's everything I wanted to say about my specialty in this presentation. Thank you a lot for listening.